Hello everybody, and welcome to this presentation on the world's simplest and cheapest test for CO2 in sleep-related infant bedding. I'm Ron Summers, and I'm an epidemiologist, US trained, working in injury prevention since 1979, first in Denmark and more recently over many years in Australia. I was the inventor of the simple test for firmness, which has now become mandatory regulation in the US and soon to be a mandatory regulation in Australia. The message here is that we would like to prevent CO2 that the baby exhales from getting captured by the sleep surface. Safer if that CO2 is dissipated into the atmosphere around the baby. If CO2 can't get into the product, then CO2 can't get rebreathed from the product. The only exception to this rule that impermeable is best is for those very rare sleep products that consist of a thin net stretched over a rigid frame. A safer mattress requires both adequate firmness and CO2 resistance. And that's because the lack of firmness acts in two ways to endanger the baby. Firstly, physical blockage of the baby's airway, but secondly and importantly, exposure to this CO2 rebreathing. My simple test, consists of some common household objects used in a clever way. Included is a can of a certain size, available both in Australia and in Europe, and available in a nearly similar size in the United States. This can in the United States is known as a US 2.5 can. So you see pictured in front of you a blue plastic cover from an ice cream container, the can itself. You see as well a plastic cup that I cut down from a vanilla extract bottle, 1/4 teaspoon measuring spoon, a little candle known as a tea light candle, 2 rubber bands, and a long wooden skewer, together with a phone or a computer on which you can time out the 1-minute delay. So the can we want, which you can buy in your supermarket, it has an outside diameter of 100 millimeters and a height of 117 millimeters, and you just use an ordinary can opener to remove both the top and the bottom lids. And then you add a concentric weight. So this is a weight added to the outside of the can using a method of connecting that interferes as little as possible with the internal volume of the can. And I've used this piece of pipe, as you can see, and I've made sure that it's centered on the can by inserting some foam spacers. The total weight with the lid should be 1,545 grams, which translates to 3.4 pounds. Now, as you see, the concentric weight that we've added to the outside of the can doesn't extend all the way down to the bottom of the can and doesn't extend all the way up to the top of the can. The bottom of the can has to remain relatively narrow so that we can create an airtight seal with the product that we're testing. And the top of the can has to be kept relatively clear so we can put the lid on. Here you can see that I've used the rubber bands to attach my wooden skewer to my tea light candle. This provides me with a convenient handle, a long handle, with which I can lower the candle onto the surface that we're testing. The cup we're using to mix our vinegar and baking soda is of a particular size. The outside diameter is 55 millimeters and the height is also 55 millimeters. And both dimensions are important. The height because the bubbling mixture might spill out otherwise onto the surface, and the outside diameter of the cup because it blocks some of the access of the CO2 into the product. So it's important that you get a container of the right size for this purpose. So the steps are simply to select the test site on the product, to add the CO2, to cover the can, to wait for a minute, then uncover the can and insert the lit candle and observe the flame. The principle here is that a flame won't burn where there's too much CO2 around, as with a CO2 fire extinguisher. So if a lot of the CO2 has entered the product, then that flame will continue burning in the can and the test is a fail. But if most of the CO2 that we produced doesn't enter the product, then the flame will extinguish. So, in the preparation for the test, you crush any clumps in the baking soda. Fill the measuring spoon with a 1/4 teaspoon of this baking soda. Level the spoon with a straight edge so we always get the same amount. Fill the cup with 20 milliliters of white vinegar. Place the can on the product at the chosen test spot and then light the candle. So this is all in preparation for the test. Now, we've got the vinegar at the bottom of that brown cup, and here you see me holding the edge of the cup even with the edge of the can. And this enables me then to add the baking soda from the measuring spoon simply by inverting the spoon and tapping it on the edge of the cup. And then I can slide the cup down while holding it against the inside face of the can until the cup reaches the surface that we're testing. And here's what it looks like just before we quickly cover it, because at this stage the baking soda has been dropped into the vinegar and it's bubbling away, and we want to capture that on the internal side of the can, so we quickly cover it with that blue plastic or other fitting cap. So here we are with our covered can, and we've waited our 1 minute, and we're just about to remove the cover and quickly slip our lit candle all the way down to the surface being tested. So a pass on this test is that the flame is extinguished on all trials over all the chosen sites. It's as simple as that. All you have to do is observe the flame and see whether it's extinguished. So that's the candle test for CO2 permeability. Any questions?